Hey everybody, congratulations on making it through week 6 of iHeart Stats. We're really getting into the home stretch now. So there's only a couple more topics and we'll be wrapping up for the course. So if you made it this far, just hang on. It doesn't get any tougher, I guarantee, so stick with us through the end. There were 3 topics that came up this week that I wanted to just touch on very briefly. Not a lot to say really. I think it seems like those who are still with us are doing well. So I'll just mention a couple of things here. The first one is on one of the homework problems, the one about the alumni, parent, and other giving to the college. There was a little bit of confusion, and we left it ambiguous on purpose to kind of make you think it through a little bit. There was a little bit of a question about 2 things. How do you get back from that data we gave you to the individual scores? Well, the answer is you can't, but you don't need to. If you go and look at the formulas that we use to calculate the sum of squares between and within and total and so forth, you'll notice that we don't need those individual scores. If that's where we start with individual scores, we have to calculate the other things, the means and the squares and so forth. But what we gave you was enough to calculate what you needed. The second part of that one that was confusing is that you do need the n, and you need the n for each group. And there was a little bit of flustering about that because people were thinking of the individual donors as being the units of analysis in this question, but it wasn't the units of analysis. It wasn't the individual donors. It was the years. So there were 5 years for each group. Those were the units of analysis. So 5 was the n for each group and 15 for the overall group. And hopefully, it seemed like most people were able to work through that, but I just wanted to make sure we were clear on that. So that's the first topic, dealing with that homework problem. The second one is an interesting question that came up, and it's one of those ones where, what I'd like to do is say, great, I'm glad you're thinking about this. You're ready for the next course where we talk about these kinds of things in greater detail. But I'll just mention it briefly and give you a thumbnail of it. And that is a question, why don't we just run multiple t-tests? We've got 3 groups instead of 2, who cares? Why don't we just run a t-test between group 1 and group 2, between group 2 and group 3, and between group 3 and group 1, and we'll have all the answers we need. We don't need to do this whole big thing with ANOVA. Well, that's true. You can run those pairwise kinds of t-tests. There's a couple problems with that. The first one is it gets complicated. It's not too bad when you just have 3 groups, but when you have 4, 5, 6, 7, 8, and so on, it starts getting really complicated to do all of those different pairs of t-tests, and it ends up being a lot more work. More importantly, though, when you do that, when you do this repeated t-test business, you actually start to lose power in the statistical test environment. And it's hard to explain that. That's a very, very complicated topic. But as you do more and more statistical tests, you start using up those degrees of freedom, and you start thinking you have more accuracy in your tests than you really do. And so you want to use the most robust test that's possible. And in this case, the ANOVA, when you have more than 2 groups, is more robust, and it allows you a better opportunity to detect differences than if you do multiple t-tests. In fact, if you do those multiple t-tests, you're tricking yourself about how accurate you actually are. Okay? So that's, again, it's a topic for another course, but it's just something to highlight here since the question came up. And then the last thing is, I wanted to highlight again that ANOVA is one technique in this little group of techniques that we're talking about now, which started with t-test, ANOVA, and next we're going to do correlation and regression. All 4 of those are very interrelated kinds of techniques. And in fact, ANOVA is a special case of regression. It's a special limited case of regression. And we're going to see more about that as we get into regression and correlation. But you can actually do an ANOVA in regression, actually. And we're not going to do that in this course because it's too complicated to add into the course at this point. But I just wanted to highlight again that these techniques are all related to each other in very important ways, and in fact are special cases of each other. Okay. And I think that's about it for this time. I hope you're doing well, and I look forward to seeing you in the last 2 modules or the last 2 weeks of iHeart Stats.